If you've been paying attention to my content recently, you know that I've become a much stronger advocate of open source. Not that I wasn't before, but I think now more than ever, it's really important that we're open sourcing our software, that we're supporting open source communities, and that we're building in a way where things can build on top of each other. I am really scared of a future where we stop open sourcing our stuff, and the software we rely on every day gets worse and sloppier with no ability to fix it. Which is why this announcement from the Cal.com team terrifies me. If you're not familiar, Cal.com is an open source alternative to Calendly. At least it was, because it no longer is open source. And this sucks for so many reasons. Cal.com is one of the first T3 stack apps, so much so that it predates the T3 stack, and we've often joked that Cal is one of the best examples of what the stack looks like. They even briefly employed Alex, the creator of TRPC, in order to improve their stack to make performance better. They have historically maintained this as one of the best full stack examples of a good, big TypeScript application. It's even been used for things like compiler tests and demos and changes to the TypeScript Go rewrite, because it's one of the best examples of a big open source full stack TypeScript Next app. And it no longer is. This sucks, especially as the follow-up to the 2 videos I just did about how open source is great for businesses and should be the direction we're moving in. And here's where I'm going to give you guys a little bit of inside baseball. I'm a good friend of the team at Cal. I've been talking with them about this for a bit now. And these conversations were absolutely in my mind when I filmed those 2 videos. That's why I even brought up Cal as an example in my most recent video on why businesses should be building on top of open source. I was hoping I might be able to put the pressure on to prevent this change, and I have failed. And I want to talk in depth about why. Why is it that Cal thinks their best bet is to close their source, and how this might doom the future of software? This one scares me, but it's an important conversation to have. And if I'm going to keep building and funding open source stuff that I care about, we're going to need to find some way to pay for it. And rather than charge you, we're just going to take a quick break for today's sponsor instead. If I told you that T3 Chat, Cursor, and Vercel all made the exact same mistake, you'd probably be confused. And if I told you we all solved it the same way, you'd probably be even more confused. And I'm sure this quote isn't helping much, but let me explain. All of the companies I just listed screwed up auth. T3 Chat and Vercel rolled their own, and Cursor went with auth 0. All of us regretted it, all of us moved to WorkOS, and all of us are significantly happier now. A long time ago, Guillermo pulled me aside because I went through this whole auth chaos where I chose to host my own auth and then realized that was a mistake. And he pulled me over because he wanted to talk about it because he had the same regret for Vercel, the entirety of Vercel. I was super scared to talk about this because I didn't want to share private information, but then he just said the exact same thing to the WorkOS team, and now it's on the site. According to Guillermo, he could have done way more business if they had partnered with WorkOS earlier. It's been incredibly well received. And there's no reason to not start with WorkOS because your first 1,000,000 users are free. Don't make the mistake we did and get auth right at soidev.link/workos. Open source is dead. That's not a statement we ever thought we'd make. Cal was built on open source. It shaped our product, our community, and our growth. But the world has changed faster than our principles could keep up. AI has fundamentally altered the security landscape. What once required time, expertise, and intent can now be automated at scale. Code is no longer just read. It is scanned, mapped, and exploited at near zero cost. In that world, transparency becomes exposure, especially at scale. After a lot of deliberation, we've made the decision to close the core Cal.com codebase. This is not a rejection of what open source gave us. It's a response to what risks AI is making possible. We're still supporting builders, releasing the core code under a new MIT licensed open source project called cal.diy for hobbyists and tinkerers. But our priority now is simple: protecting our customers and community at all costs. This may not be the most popular call, but we believe many companies will come to the same conclusion. To tie all of the chaos of things going on right now together, Project Glasswing is something worth thinking about. You're not familiar, you didn't watch my video on Claude Mythos, and I would recommend going to watch that first, as well as my video on security of software as a whole, because the security field is changing on a fundamental level right now. Historically, there was a very small number of people that knew software and security in software well enough to be useful for not just finding things that could be wrong and helping companies fix them, but really being able to build up and exploit these types of deep security flaws that exist in all of software. In order to be good at exploiting software, you need to understand software well, you need to understand exploits well, but you also need to understand how the specific software that you're trying to exploit works, where its edges are, how the parts interact, and much more. It is possible to build a good understanding of those things externally by reverse engineering the binaries, by trying to look at the compiled source in the JavaScript apps that we're all using every day. There are lots of strategies to try and build that deeper understanding of the systems that you're trying to break, hack into, or find exploits in. Those things get a lot easier when you can read the source and see the relationships between those parts. And they get even easier if an AI can build the same understanding. The how exploits happen function is relatively simple. You have somebody's security knowledge, effectively, multiplied by their domain-specific knowledge. The combo of these two is what makes for big exploits. Somebody who understands the domain they're in, whether that is the actual source of the code they're working with, whether it's the system the code runs on and the quirks of that system. The domain that you're hunting in is really important, just as much as the security knowledge. Historically, the number of people who have either of these was low. So in a given domain, the people who understand the domain and the security aspect was often even lower. So something like cal.com was not a great target because people who knew security really well didn't know how to go through a big full stack TypeScript project. So it being open source didn't meaningfully change the average security researcher's domain specific knowledge because they didn't understand full stack TypeScript. So having a full stack TS code base did not meaningfully change their capability in that code base and for that project. I'm sure most of the people in my chat here are developers. So I would like all of you to drop in chat a number between 0 and 10 for how confident you are in your capabilities as a security researcher. If you're given a code base, how confident are you that you can find and identify the security issues that might exist in it? I haven't seen any number higher than 3. I saw negative 100. NMG, who is like a person I literally pay to do security audits of my shit, dropped a 6. Most of these numbers are significantly lower. This is the issue. People who are strong on one side, like here with the domain. So if you're really good at TypeScript, the likelihood that you're good at security goes down. And if you're really good at security, the likelihood you know jack shit about TypeScript goes down too. So while AI does not necessarily have a ton of knowledge about security stuff, what it does have is weird domain knowledge on everything else. So if you take a full stack TypeScript application's source, the AI can understand the domain specific stuff. And all you need is a little bit of security knowledge to push it over the line and find real exploits. So previously, to find exploits, you would have to be like a 7 out of 10 on both sides. Now, with the models being so good, you can literally be a 0 or a 1 out of 10 on the domain-specific knowledge side. And the security knowledge side, probably also lower because you can just throw so much shit at the wall, like a 4 out of 10. And now at this level, you can find real, legitimate, concerning exploits. That is a huge change. We went from like maybe a few thousand people in the world had this capability to the majority of people who have done a CTF before suddenly can. That gap is what's so scary here. AI has made it so the amount of domain-specific knowledge has hit the floor, and the amount of security knowledge needed has also gone down quite a bit too. If you think this is only a thing for poorly coded full-stack TypeScript devs, I would like to remind you that Mythos Preview found a 27-year-old vulnerability in OpenBSD. OpenBSD is one of the most carefully crafted and maintained code bases in the world. It is the only Linux alternative that is almost inarguably way more secure than Linux, that is focused on being a reliable core to power everything from our routers and our firewalls to power lines and shit. OpenBSD being pwned by AI is terrifying, but part of why the AI could do it is they targeted the source code. The way Anthropic did these vulnerabilities was writing a script that would go through every file in the code base and spin up an agent saying, we are looking for CVEs and potential exploits in this code base. Start from this file and trace the system to find anything that might be interesting. They're effectively using each file in the code base as a starting point, as a seed function almost, to make more outputs happen. And just by running this across every file in the code base, which, mind you, it's not staying on the one file when it runs, it's just the entry point. So it starts on this one file and then goes through the code base looking for other shit. They did this before with Opus as well, yes, but they did it with Mythos here and found a ton of scary shit. None of that requires crazy hacking expertise. That's like a clever idea most 15-year-old vibe coders could have come up with. And somebody said, so they're effectively training it to help hackers better? No, absolutely not. That's not a thing that they did in training. That was an experiment they did with the model once it was trained. They did not train the model to hack. They trained it to code. And the point I'm trying to make here is that the model's getting better at code means that half of this function has collapsed. The two blockers for a random person finding huge exploits and pwning the world are they don't know enough about security and they don't know enough about the domain. Now, the domain knowledge doesn't matter anymore. So the only thing blocking is security knowledge, and even that bar has gone down. You just need to be a little clever now and have enough money to burn on tokens. That's it. And that is scary. And if one of the methods here that works is brute forcing by telling a model to start from every file and trace everything, that's a lot easier when you have the files. These AI models and the agents and harnesses they use are capable of doing crazy deobfuscation work where they can take a compiled program or minified JavaScript and unfuck it in a way where they can start to understand what's going on under the hood. Enough so to find some security issues, but these models are way better at doing it when they have direct access to the source. So again, to go back here, if this is the function that we're thinking of, if the code is open source, the model has all of the tools and techniques it needs to pwn that domain because it has the source. It knows how to navigate source code well. It understands code. It will destroy here. It doesn't understand deobfuscation and reverse engineering as well. So it's not going to be able to decompile as well as it could parse existing known source code. So if you hide the source, the level of domain expertise needed to do well here probably bumps back up to like a 4 out of 10 for now. But what happens when the models get good enough at deobfuscation and decompilation? This will also fall back down to a 1. So my first argument against what Cal has done here is simply that they have only bought themselves time, and they've not bought a lot. They are terrified of the bar for finding exploits going down, so they have done this change to temporarily bump it back up a little bit, not where it was 5 years ago, but a place that's a little more reasonable considering how powerful this AI stuff is. But I would suspect this advantage will be lost soon too. Good point from Aiden here. Doesn't this assume that you always have the binary so you have something to decompile? Unless you can scrape and find backend endpoints and techniques from the front-end clients. There you go. That's the key there. You can do enough scraping to make up for some of the difference here. On one hand, the client will give you access to everything that the client connects to. In this case, all the endpoints that it uses. So you can get a lot from that, but you don't have the backend code. But you do have all of the services that are hit and infinite time. That's the other thing that I didn't include here that is definitely worth including. Time. How much time do you have to test these things and do these things? People who are strong in security knowledge and the domain-specific knowledge are often strapped for time. So the likelihood that these people have enough spare time to pwn your random open source thing was very low. But what happens when you have a bunch of agents that don't care about time, that you can just let run overnight for hours at a time and just run in loops constantly trying to find things they can exploit? That's when you end up with a CVE shitstorm like we're in today. So what have others had to say here? Tanner jumped in almost immediately, saying that if AI reading your open source code is hurting your business, you are likely using open source as a growth strategy instead of a philosophy. And closing it now doesn't make you secure. It just means fewer good faith developers are hardening your code and more bad actors are pointing AI at your production servers. Oh boy. It's a good take, but there are layers to this. On the topic of hardening your code, this is also a thing worth talking about. OpenAI dropped a new model today, GPT 5.4 Cyber. The point of this model is that it can be used to harden your code bases ahead of time. I believe you have to get whitelisted to have access. I don't even have access to it yet. But the point of it is to make it easier for companies and businesses and developers who are building important software to be able to harden their software before agents are used against them. Security is always an arms race between the people trying to secure their software and the people trying to exploit it. The loop's about to get tighter. And I'm thankful that both OpenAI and Anthropic are putting extra effort in to make sure the people building this software have a chance to fix it before these tools are in the hands of potentially bad actors. Attackers and defenders are the official industry term. Thank you, NMG, for keeping me on point when I'm talking about these things. With decompilation, I see reasonably it will always converge. With security exploits, I'm not sure if it's the same. I don't think decompilation will matter too much here for the back-end side in particular, but it will let you decompile the front-end side, figure out what endpoints are hit, and then brute force try to break through those things. There is a very real security issue here, and I don't think most of us, even the best developers I know, have really had it click just how fucked we are. The only reason that we're not getting pwned constantly is that it took too much effort from too much elite attention from really smart people that have a wide breadth of knowledge. And those people, it wasn't worth their time to find exploits and random shit. That's changed. And that change is what's so scary. But as Peter says here, if you're not familiar, Peter's the creator of OpenClaw that's now at OpenAI. If you look at GPT 5.4 Cyber and its ability for closed source reverse engineering, I have bad news for you. I do very much feel the pain though. There's hundreds of teams that try to poke holes into OpenClaw. Our response has been of rapid iteration and code hardening, which did introduce occasional regressions, and yes, you've all been yelling at me for it, but I see it as the only way forward. I would be very careful of other open source projects and harnesses that ignore this work and do not publish their advisories. Simon Wilson also chimed in here and linked a really interesting piece from Drew. He argues that the cost of locking down software through LLM analysis makes open source more valuable now. Cybersecurity looks like proof of work now. Is security going to spend more tokens than your attacker? If you're not familiar with proof of work, this is a concept that is largely popular in the crypto world, but is also popular for things like CAPTCHAs as a way to slow down negative, harmful work. So for crypto, it is a way to prove that this transaction is real because real compute went into signing it and thumbsing it up. For more traditional CAPTCHAs, it is a way to solve a complex problem that takes real CPU usage before you're allowed to do an action. So if we implemented a proof of work CAPTCHA on T3 chat, your computer would have to spin up its processor and do something to prove it's a real actor before going and doing whatever thing you want to do. The reason you would want to do something like this is because you want to make attacking your service expensive. If we didn't have CAPTCHAs on T3 chat, you could use our endpoints to generate things for free effectively by just hitting a random endpoint on the free tier and generating a response. Proof of work is a way to make that too expensive by you not being able to just bot it out. You need computers with real processing power to get approved by solving the puzzle and doing the work and proving that real compute went into doing a thing. So saying cybersecurity looks like proof of work now is saying this comes down to spending power. Who's willing to spend more? If you can cost me $1 using one of my endpoints and the proof of work only costs you 50 cents, you just found a way to save 50% of your spend by spamming my endpoints. So balancing this out, so the side that is trying to exploit has to spend more than the result of their exploitation, that's the complex balance. If it only costs you 50 cents to take $1 from me, you're going to take a lot of money from me. But if it costs you $2 to take $1 from me, you're not going to do that a whole lot. And that's where we're going with cybersecurity. Who's spending more? The security side or the attackers? This is both a very scary and a very real framing. Last week, we learned about Anthropic's Mythos, a new LLM that is so strikingly capable of computer security tasks that Anthropic didn't release it publicly. Instead, only critical software makers have been granted access, providing them time to harden their systems. We quickly blew through our standard stages of processing big AI claims: shock, existential fear, hype, skepticism, criticism, and finally, moving on to the next thing. I encourage people to take a wait-and-see approach, as security capabilities are tailor-made for impressive demos. Finding exploits is clearly defined, verifiable search problems. You're not building a complex system, but you're poking at one that already exists. A problem well-suited to throwing millions of tokens at it. Yesterday, the first third-party analysis landed from the AI Security Institute, largely supporting Anthropic's claims. Mythos is really good. A step up over previous frontier models in a landscape where cyber performance was already rapidly improving. Their whole report is worth reading, but he wants to focus on this chart, detailing the ability of different models to successfully complete a simulated, complex corporate network attack. This is scary. Opus and Mythos have made meaningful improvements in how many steps they can complete to get to a task like reverse engineering in crypto analysis, where 5.4 is just over the line for wiki exploitations and credential replay. Yeah, this is a very scary chart. This benchmark, called The Last Ones, is a 32-step corporate network attack simulation spanning initial reconnaissance through to full network takeover, which the ASI estimates would require humans 20 hours to complete. And this is qualified humans who really know what they're doing. The lines are the average performance across multiple runs, 10 runs for Mythos, Opus 4.6, and 5.4, with the max lines representing the best of each batch. Mythos was the only model to complete the task in 3 of its 10 attempts. And that's what this line is. The max is it succeeding, and it was able to do the full network takeover. It's the only model that's ever been able to do that. Terrifying. The chart suggests an interesting security economy. To harden a system, we need to spend more tokens discovering exploits than attackers spend trying to exploit them. The ASI budgeted 100 million tokens for each attempt. That's $12,500 per Mythos attempt, $125K for all 10 of the runs they did. So $125K for 3 of the 10 runs to actually succeed. That's a lot of money, but that's still really scary. Worryingly, none of the models given a 100 million budget showed signs of diminishing returns. Models continue making progress with increased token budgets across the token budgets tested. If it does continue to find exploits so long as you keep throwing money at it, security is reduced to a brutally simple equation. To harden a system, you need to spend more tokens discovering the exploits than the attackers will spend doing the exploits themselves. You don't get points for being clever, you win by paying more. It is a system that echoes cryptocurrency's proof of work system, where success is tied to raw computational work. It's a low temperature lottery. You buy the tokens, maybe you find an exploit, hopefully you keep trying longer than your attackers. First, open source software remains critically important. For those of you who aren't exposed to AI maximalists, the statement feels absurd. But lately, after the light LLM and Axios supply chain scares, many have argued for re-implementing dependency functionality using coding agents. Here's Carpathy from just a few weeks ago. Classical software engineering would have you believe that dependencies are good. We're building pyramids from bricks. But in his opinion, this has to be re-evaluated, and it's why he's been so growingly averse to them, preferring to use LLMs to yoink functionality when it's simple enough and possible. If security is purely a matter of throwing tokens at a system, Linus's law that, given enough eyeballs, all bugs are shallow, this now expands to include tokens. If corporations that rely on open source libraries spend to secure them with tokens, it's likely going to be more secure than your budget allows. Yeah, because you're effectively combining the budgets on either side. To go back to the example here, these runs had a 100 million token budget. 3 of the 10 succeeded. But if you imagine that as 10 different orgs, 10 different exploiters spending, there's no way that one's spend benefits the other. So it's not additive. But if 10 different groups contribute 100 million tokens to securing a project, those are additive. So if the bar to find an exploit at the 50th percentile is 200 million tokens, and we are assuming that it's roughly matched on the security side, 3 people putting in 100 million tokens is going to secure relatively well on average against the 1 person spending 200 mil tokens to hack it. So while these open source projects with lots of companies putting effort into securing them should be more secure, there is a complexity here. Cracking a widely used open source project is inherently more valuable than hacking a one-off implementation, which incentivizes attackers to spend more on these big open source targets. Second, hardening will be an additional phase for agentic coders. Already been seeing developers break their process into 2 steps, development and code review, often using different models for each phase. As this matures, we're seeing purpose-built tooling meeting this pattern. Anthropic just put out a code review product that costs $15 to $20 per review, which is still absurd, but yeah. The above mythos claim holds, I suspect we'll see a 3-phase cycle, development, review, and hardening. Development is when you implement the features, iterate quickly, guided by human intuition and feedback. Review is when you document, refactor, and do other gardening tasks, async, applying best practices with each PR. And then hardening, where you identify exploits autonomously until your budget is out. Critically, human input is the limiter for the first phase, and money is the limiter for the last. This quality inherently makes them separate stages. Why spend to harden before you have something? Previously, security audits were rare, discrete, and inconsistent. Now we have to apply them constantly within an optimal, we hope, budget. Code remains cheap unless it needs to be secure. Even if costs go down as inference gets optimized, unless models reach the point of diminishing security returns, you still need to buy more tokens than attackers do. The cost is fixed by the market value of an exploit. Yep. This is a phenomenally put article. And I agree that we need more spend power on the things we all rely on, which means we need more effort going in to open source right now. This also means that open source projects are going to need to do a better job of embracing this way of spend. If a project like FFmpeg is going to refer to this spending finding security stuff as CVE slop, we're going to have a problem. Google spent a shitload of money trying to find exploits in open source software, and they gave FFmpeg a huge 3+ months heads up about an exploit that they found in a barely used codec within FFmpeg. That codec is included in most FFmpeg installs, so it is a very real, legitimate issue, but they flagged it as low severity and ignored it, and then when it came out, they flipped a shit on Google for it. This isn't going to work. Part of this new system where proof of spend effectively is necessary for security, open source maintainers have yet another burden they have to deal with, and I hate that part. It genuinely sucks that open source projects have to eat more work than before, because now not only do they have to try and make a good project, deal with all of the bullshit they get in through issues and whatnot, and do their best to make it secure, they now have to deal with all of these security reports coming through all sorts of different channels and doing their best to stay on top of it and maintain it. It is thankless work. It is important work. But pretending this work isn't important and referring to the people reporting these things as creating CVE slop with AI is absurd. And yes, FFmpeg did block me after I donated $5,000 because the guy who runs the Twitter account's a pussy, but that's a separate thing. I will resist the urge to tell you guys all about the different maintainers of FFmpeg that have hit me up complaining about the person who runs the Twitter, because the FFmpeg Twitter account is not run by a maintainer. Just saying. Regardless, we need to not have this attitude. That is why this is here, because this is dangerous. And if hackers realize FFmpeg is ignoring the attempts to make it more hardened and safer, they will target it with exploits. You don't need permission from the open source maintainers to exploit their software, but you absolutely need their permission to fix bugs and security issues in their software. So if the maintainers aren't willing to embrace the feedback they are getting about potential security stuff, the hackers will take advantage of that gap. I think I've said all I have to on this one. I understand where the Cal team is coming from here, and I also understand that other businesses aren't going to be interested in helping fund them securing their stuff with tokens, but I still hate seeing a great open source project go closed. And I have a bad feeling this is far from the only time we're going to see this type of thing happen. Keep fighting for open source, keep doing what you can to support the projects that we all use and rely on, because otherwise the future is going to be closed. I still believe open source is the best thing for most businesses. Go watch my previous video if you want more info on that. But for now, we have to push hard to convince companies that this is the right call going forward, because more and more of them are going to see these exploits, assume that open means bad, and then shut this down. And we cannot let that happen. We cannot let fear-mongering kill open source. So keep fighting for what's right, keep pushing to keep things open, and keep working to keep the tools we use secure, reliable, and great. And until next time, peace, nerds.